Imagine a time when the very thing that gives us life, oxygen, was once a deadly poison. Roughly 2.4 billion years ago, the Earth's atmosphere began to change in a way that would set off a chain of events, leading eventually to the greatest explosion of life the planet had ever seen. But before that explosion, there was something else, a silent killer, and a global catastrophe that nearly ended complex life before it could even begin. To understand what happened over 534 million years ago, we have to look at a strange period in Earth's history known as the Cambrian. This was when life, as we know it, seemed to explode in complexity. Fossils suddenly show creatures with eyes, legs, shells, and body plans we'd recognize today. But just before that, something nearly wiped it all out. A scientist named Dr. Graham Shields Jew, a geologist at University College London, has spent years studying ancient rocks from China, Mongolia, and Namibia. What he and others found was startling. Signs of a rapid oxygen surge followed by a deadly crash. You might think more oxygen is always good. After all, it powers our cells, fuels our brains, and supports everything from insects to whales. But around 541 million years ago, as the Cambrian period was just starting, oxygen levels in Earth's oceans spiked. And that's where the trouble began. Oxygen, it turns out, can be toxic. At high concentrations, it becomes a cellular wrecking ball, damaging proteins, DNA, and cell membranes. For life forms adapted to low oxygen environments, this sudden change was catastrophic. A dramatic oxygenation event triggered oxidative stress on a global scale, killing off countless microbial ecosystems that had thrived for billions of years. In 2018, a paper published in Nature Geoscience by Dr. Emma Hammerlund and colleagues provided compelling evidence from fossilized microbial mats showing signs of severe ecological collapse. The oxygen levels rose too fast, and the organisms simply couldn't adapt in time. This event is known as the Cambrian Oxygenation Event, and it marks a point when Earth's atmosphere reached a tipping point, pushing life to the edge. But here's the twist: this deadly wave of oxygen may have also been the very pressure cooker that forced life to evolve. You see, when oxygen rose and wiped out the simpler, more passive organisms, only the adaptable ones, those with stronger cells, efficient metabolisms, and protective features, survived. This brutal selection may have driven the sudden appearance of hard shells, complex eyes, and fast movement in animals. It's like a global stress test that only the fittest could pass. One of the most mysterious creatures to appear shortly after is Anomalocaris, a fearsome predator with grasping limbs and complex eyes. Without that deadly oxygenation spike, it might never have existed. Nor would trilobites, early arthropods with complex exoskeletons. They were built to survive a new world, one full of oxygen, predators, and competition. In fact, the very foundations of animal life as we know it, nerves, muscles, blood, and bones, are all deeply tied to the oxygenation of the planet. Without that terrifying brush with annihilation, the biological leap to complexity might never have happened. Dr. Timothy Lyons, a geochemist at the University of California, puts it best. Oxygen didn't just allow life to flourish, it forced it to adapt, to innovate, to become something new. So the next time you take a deep breath, remember, the air you breathe is a byproduct of death, destruction, and a billion-year-old arms race. What nearly killed everything might have saved us. And here's the real question, one that scientists are still trying to answer. Could it happen again? Not in the same way, but oxygen isn't the only invisible force that can flip the balance of life. Our atmosphere today is changing again, not through oxygen, but through carbon. And just like 534 million years ago, the winners and losers of tomorrow may already be written in today's invisible gases.